Okay, it's 1 o'clock, so we'll go ahead and get started. Just wanted to thank everyone for attending today's roundtable, Insurance and Claims Fraud with Graph and Machine Learning. Before we get started, just wanted to go over a few things with everyone on the call today. There will be time at the end of the webinar for a Q&A, so if you have questions, feel free to drop them in the Q&A box at the bottom of your Zoom meeting, or feel free to chat the panelists. Also, we are recording today's session, so you'll be receiving an email later this week with a copy of the recording. And if you have any questions or issues during the webinar, feel free to reach out to me, Expero Internal. I'm the host, and I can help you out as best I can. With that, we'll go ahead and get started. I hope you enjoy today's presentations, and I will turn it over to Scott, Graham, and Chris from Expero.
Hello, everyone. My name is Scott. I'll be part of the tour guide group today. I've got with me a distinguished panel, Graham Gansel, who will be talking to us about sort of the details of how we're going to talk about what we're going to do today. And then Chris LaCava, who will show us some great insights and the art of the possible. What we have on tap for you is I'm going to sort of lead off. We're going to talk a little bit about sort of why insurance, fraud, policies, and claims are sort of all intertwined and why it's such a big problem. Second, then Chris will take us into an art of the possible, show us specifically how we can do some tangible mitigation of what those things are. How do we see it? How do humans react with it? And then finally, Graham will follow up with effectively how we're going to do what we're going to show that looks so easy and what is going on with some of the technology. So that's what we have on tap for you today. The first screen here, everybody knows, right? Right now in insurance, we're stuck in a lot of different ways. So whether you're, in the special investigations unit, or you're in the claims group, or underwriting, or even on the front lines with customer service reps, right? There's a lot going on. Specifically, the FBI is telling us now that it's getting worse. So COVID has made it more likely that we're going to start to see all kinds of insurance fraud, right? So whether it's upcoding, mischarging, it's starting to do more of a claims ring, et cetera. And the numbers are starting to get staggering, right? So whether you're in property and casualty, whether you're in health insurance or disability, et cetera. The second thing that's starting to do is as we have our third-party broker networks, right? So now we're starting to see people in the middle where they don't have an affiliation. So maybe we're working with our third parties and we're starting to do that, right? So how do we start to uncover some of these more sophisticated ones where they see gaps in the system, they see the stress that's going on out there, and they're starting to do it, right? So we're seeing now these people, and even doctors or claimants, right? So if we're doing auto and car theft, and we'll see that today, right? Sort of as we see those claims that should be unrelated, there's groups of people that are working together, right? And as we're doing that. And then the third one is something like AML, right? Anti-money laundering has now been added to the pile as far as regulation in what we're trying to do. And we're starting to see people where they're, prepaying on life insurance, and then they're starting to collect their deductibles, and then they're starting to do kinds of things where they're laundering our money. So if anything, it's getting more complex, and the numbers are getting bigger. When we start to look at now distilling what that really means, right? So when we look at this little pictogram here, where we talk about all the kinds of insurance, right? We look at life insurance, we look at death benefits, we look at auto and casualty, et cetera. The bottom line is, as an aggregate, only 1.7% of that is being prosecuted successfully. That is awful, right? So how do we start to get in front of this? How do we use technology? We've got more than ever all these sort of vectors, if you will, that are coming at us. How do we start to get smarter? How do we use technology? And how do we use our humans? That's the other big thing you're going to hear today, is that we can't forget about our investigators. We can't forget about the knowledge that our humans have as we bring in new and junior resources. We want them to be at the same level as our senior folks. And so what we start to see now are these items over here, right? Which is, it's getting more expensive, right? They're becoming more organized and adaptive, and we need to become more organized and use the tools and automation to do that. The other thing is it's no longer a simple sort of connectivity type of an outlier where we're doing this. And then look, our compliance for states and then our compliance for federal, they're all getting more and more stringent. They're getting more scrutinous, right? And then we're all being asked to do more with less, right? How do we sort to do that? And then so many new technologies are sort of exploding on the scene. Those are some of the backdrops. So what we hope to do today is to sort of lean in on these, give you some methods and give you some hope, if you will, on how to do those things, right? So if you listen to Gartner, there's a new technology and this sort of integrated link here. What we see then is AI and machine learning is emerging. We're hearing that word everywhere. Just put a little machine learning on it and it'll get better. Graham's going to share with us sort of what that really means for practitioners and how to do that. Data fabric, some of these other kinds of things. We can't do it unless we connect to all this data, right? ETL has gotten slower and we want to do it in real time. But the final linchpin here, again, is if you listen to Gartner, is a technology called graph. Now, graph is not a pie chart. Graph is not a line chart. It's a new way of thinking about connected data in a different way. Now, we don't believe that graph is going to eat the world and take over all those SQL databases that are out there, but it is very much a lift when it comes to the insights, the capability, and the time to turn around sort of potential fraud. So Gartner is pointing us in that direction, and we'll talk a little bit about what that is today. The next thing then is, what is graph? Well, I can find paths, I can find communities, I can start to find centricity, similarities, and predictions and connectivity. Those are all terribly important when we're looking at insurance. We're looking at sort of what those kinds of things are as we look at those inside of how we use machine learning as we build a smarter system. So these will become interesting concepts. Now, you can build systems that we're going to talk about today without graph, but we're going to show you some things that are interesting. And the beauty of what it is it's a bolt-on technology. Now, at Expero, we're consultants, so we work with lots of customers in lots of different ways, and there are different vendors that are out there. There are certainly some that are good and better than others, and we have lots of other series where we can talk about that. But again, graph is going to be one of those ingredients as we get closer to building that. Now, when you're looking at certain kinds of things, our friends at McKinsey lean in as well. And they're saying, well, in the medical or Medicare and some of the other claims data, there's more to it, right? And these are all very similar attributes that we're going to see whether you're in property, casualty, or auto, which is taking the record of the customer, taking the history of the customer and their claims, right? Being able to connect all of that data and then being able to create this digital ecosystem. Well, in this particular example, McKinsey is mentioning sort of health, but it is very, very applicable across the board. So whether you're doing health claims insurance or you're actually doing some of the other ones, this sort of connected web is where we're going with that ingredient of graph. Now we start to look at what are the core drivers. We start to look at matching the data in our current systems, right? That's the master data element. How do we find out if it's fraud or is it just inefficiency or inflation, right? How do we figure out if we paid a claim, do we get it back? How do we, quite frankly, stop it before it goes out the door? When people are creating claims, so maybe my car had a $200 damage, right? How do I figure out sort of, is the body shop trying to fleece me on something that's an inflated claim or a misstated claim, et cetera? What are the policy histories? What are the risks on certain policies that perhaps may be more attributed with some sort of fraud or claims history? And then let's go all the way to the other side, which is underwriting. How do we write better policies? How do we use the data from our fraud potentially and our claims and the policy, right? How do we build better ones? And then how do we create better compliance reports? Same thing with AML. Right. So now that AML has sort of landed on the scene for insurance, we still have to fill out SAR forms for FinCEN, even though if we have suspicions, and this is getting a little larger over time, and some of the charts show us that. How do we sort of start to predict where these things are going? And then ultimately, if we do decide to prosecute, how do we build better cases? Those are all the drivers in what we're going to talk about today. The other part of what we're going to see here when Chris shows us is, let's see what this looks like. Let's let a layperson take all those great use cases and all the deep elements, and let's put it in terms that a human can understand. Let's take this high availability and real time and connected information, and let's see it. The other thing that Graham's going to show us then is how did we get there? How do we create patterns? How do we look at what ifs and predictions and scores, right? That's how all three of these sort of fit together. And then that's what we're going to be exploring today. Now, for those of you that see the different use cases, this is actually connected to our customer. So somebody who's buying the insurance or a third-party broker who may be in the middle, who's selling the insurance for us to our end customer. We see that at the top, but we see these dotted lines over on the right and the hard lines, which is these are how these things connect together. So even though we are not talking about the KYC or our customer data, we still very much depend on what those things look like to start to give us indicators of what could be fraud, what might be a mispayment, or people that may be doing claims inflation and those kinds of things as we get into the use cases down at the bottom. And again, our goal is to make more money, be more profitable, decrease our cost over on the left, and then quite frankly, mitigate our risk. So part of the supposition for today is that using these advanced technologies and what we see in our orange band is good. It's better than what we've been doing previously. And that's great. And many of our customers are doing that today. Many of our large conglomerate ones who are offering multiple lines of insurance, whether it's again, property or business or personal. And then some of our other medical insurance folks are doing that for claims and claimants as they're sort of paying Medicare and getting paid by Medicare and pay or payer, they're starting to see this. And that's what this baseline is there to do. What we're starting to see now empirically is that using a graph and machine learning, we can start to get better accuracy. We can start to get more accurate insights, and we're lowering our false positives. And then layering on now what we're going to see in the visualization is that we can get together as a combined now this boost of roughly 11%, in some cases even higher. So that's really kind of where we're going. Now, the one for AML fraud detection was a fairly small use case. And what we were doing there was the insurance component, right? And by creating this, they were able to get an 8.9% accuracy increase. Now, there's a few links down here that talk about sort of how we do that. And those are authored by Graham. So please go check those out. But the point of that is we have tangible results. The same thing in our next use case was claims upcoding in an ER style data set. And we took the same data set that was being used today, and then we didn't do anything different other than apply that new methodology, and we were able to find an additional 6%, right? And that was only in one small business unit. So the point of this is real. These are real numbers. And now let's sort of decide and show sort of how we got there. Well, one thing about insurance that we all know for sure is that it's complex. Right? What's happening now is insurance has sort of these three, and there are multiple categories, but the point of this is to start to dip our toe into why this is so hard and why this type of technology can help. So over on our left is we have insurance products, right? We have hierarchies, distributed hierarchies of different products, different sort of sub products for each state, right? So the complexity then is what are the rules there? What are our federal rules? What is the lineage of those products? Some of those products been around for a long time, and the contracts and the policies that have been written with those are ever so slightly different. So we start to get branches that get deeper and deeper. Well, that's complex on its own. Then we start to see this connection of customers. What are their membership? What products? They may have multiple products. They may have time. They may have risk. There's underwriting that's gone in that as those get contracted, right? And those start to show as more connected networks, if you will, of products and who they're related to and their family and people that are on policies. And you may have a company that has sub employees, et cetera. And so you start to see more of what you see there is more of a connected and sort of segmented style graph. Then you get into the back office. So what were the claims? What got paid? What got denied? What were the original risk calculations? What are the underwriting, right? And now you start to see a very explosive sort of connected set of data that also may have hierarchies, et cetera. Well, the good news and the bad news is all three of these are all now connected. And what you can start to see visually is that if I have a connected set of data where I can see all of these connections, and I can leave that data where it sits, by the way, I can leave it in my existing SQL systems. What I want to do is to start to do some smart calculations on predictions, right? Where I'm looking at the connections, not so much the data that's stored in tables and indexes and those kinds of things. I want to move it up a higher order. So that's why insurance is uniquely qualified for this kind of a solution and sort of where we're going in some of the demos. Now, this is just a simple indication, right? So a pattern starts to emerge, right? We start to see a claimant who may be working with a doctor, and Graham's going to talk more about this, right? That has an address that's in common that should not be. That pattern is not easily detected because these folks know what they're doing, right? Some of our older methods are, well, if the claim's too high, let's say the claim value is out of range, or something is different, right, or out of whack, then I can easily catch that. Well, these kinds of things that are happening now are not really falling into those, and we need this sort of additional and higher order, if you will, to go find those. Well, our process hasn't changed much, right? So what are we trying to do? We're trying to find it. We're trying to see the pattern. We're trying to solve it or manage it through a case or adjudication process. And then we're trying to document it, right? So what did we find? How did we find it? Are these things connected? How did they get connected? When were they connected, right? And then we say, well, now we'd like to teach the system through a series of what if models or other kinds of things to say, we'd like for you to learn and then go stop it now, flag it before it actually gets paid. Let's cancel that claim before or it actually comes in, and let's try and do that, right? The other thing that's adding complexity to this is we're not the only ones. So we may be working as a pod or a unit over on the left in special investigation. We may be looking at certain categories. You may have a red group or a blue group, which are high value claims that you're investigating, and others are smaller, or you may have more complex cases, et cetera. But the data is now separated by these need to know and separate teams that are investigating. Well, we'd like to take that capability and allow the learnings from those teams to be able to share without actually sharing all the data. Maybe your organization, you actually want to share all that. And again, that's kind of up to you. But the goal here is to take those kinds of requirements as an ingest here so that now we can create SARs or action reports or claim prosecution, et cetera. That kind of complexity is what Chris is going to share with us in some of these other demonstrations and moments that we talk about. Okay, well, why do it now? Well, the first thing is we're seeing these members, the claims, right? The pressure is on us, right, for COVID. We're seeing this big uptick. The technology is out there, but it's hard and there's a lot there. But we are being asked to do more with less money, right? The cloud is out there. We can do incredible things with the cloud, but do we want to put our PII data out there? How do we encrypt it and do those kinds of things? It's got to be fast. It's got to be elastic. And then we start to see this visualization, right? The rise of the cool Python notebook and some of those kind of things. And Graham's going to tell us about that, right? So how do we do that at cost and how do we save money? Now we start to see Amazon, right? They've come to us and shown that we can do this kind of data analysis right now, right? They can do it. Why can't we do it? We should be able to do that. We do as much in what they do, right? The state and local regulations are getting higher and more stringent. So we need to take that into account as we start to do that, right? As we get new diseases like COVID and that reaction time, we can't be caught off guard, right? We have to be able to do those kinds of things. If we're doing medical claims, right, there are outcomes and comorbidities that we need to react quickly because lives are on the line. Regulatory, right? Again, this whole policy state by state, data portability, we have to sort of seamlessly integrate all these things. These are all now why now is really the time to act. Well, let's pause there, right? So what we want to do now is let's take a moment. Let's talk a little bit. I'll throw the ball to my counterpart, Chris, and he'll talk about sort of how we take those inputs and then let's do an art of the possible. So Chris, over to you.
Great, thanks, Scott. Where I'd like to start is just talking about some of the different users that are interacting with the data that Scott had mentioned, and some of the use cases around this data and how we build solutions to basically try to wrangle a lot of this disparate information into something that's highly connected that we can start to analyze. So the first thing I want to talk about is just the fact that this is a very heterogeneous landscape. There's a lot of different people interacting with these systems. There's a lot of different use cases. Just the continuum within, the larger domain of insurance is highly variable, and it's very distributed. Most workflows are multiple levels of approval. You're dealing with multiple levels of adjudication in some cases. There's a lot of chain of custody that has to be managed. And Scott had mentioned this, but now that technology enables us to link a lot of this data together to see a continuous view of a lot of this information, it can be very overwhelming to the user. So now what used to be very siloed systems, legacy systems with siloed data that couldn't be shared, we've managed to unlock a lot of that with technology. Scott mentioned a graph database is one way to do it, but highly connected data in general allows us to see that big picture. And now we can analyze it, and Graham will talk about some of the analytic tools that are available to us. But what I really want to dig into is how do we make that make sense to our heterogeneous user groups. So we have, from one side of the spectrum, executives trying to look at strategic aggregate information, all the way down to data engineers and data scientists running algorithms. And in between, there's a whole host of people interacting with this data, such as investigators and case managers and providers and patients and all sorts of people. So even if we unify the data, the view into that data has to be specific to the user persona. And now that we've got a lot of technology at our fingertips that we hadn't had before, we can start to view that information in novel ways. Next slide, Scott. So let's talk first about just visibility into connectivity. As I mentioned before, these things were often very siloed pieces of information that we've now linked together in a continuous set of records. That allows us to run analysis and basically discover things that we never knew, because we never could make those relationships tangible within one unified view. So a lot of the analysis tools that we'll be going through today are basically the ability for users to be able to look at that huge amount of data and see it in a very connected, ordered way so that they can start to do that analysis. And on the next slide, we'll talk a little bit more about how we look at temporal information. So now, not only can we link these things together, but we can see how they progress through time. We have a contiguous view of how events begin and what their outcomes are. In siloed systems, it's hard to do that. But when we connect that information, now use cases such as claims investigation or just looking at a patient or member journey through a set of interventions, for example, we can start to see the full record and do analysis or investigations on that. So we have temporal information that we can play forward and back. And again, we'll look at some specific details of this in a few minutes. Next slide, please. Also, where things transpire is often very informative. So, in the case of money laundering, or if we're looking at credit card fraud, for example, not just the time in which it took place, but the places that things actually occurred can give us clues into how to look into certain investigations. It can also give us clues into fraudulent activity just by virtue of people not being able to conduct the same activity potentially in the same place in the same time. So it gives us a hook into being able to not only visualize how things transpire in geospace, but also if there are anomalies that just are impossible, we can see that in the data set just by looking at where they transpired and when they transpired. In addition to that, it just gives us heat maps and allows us to link into deeper analytics. So now we can start to see not only from a geo perspective, but also a segmentation perspective. So we, with that high connectivity and those rich set of relationships through the continuous set of data that we have, we can start to segment that and see different communities. We'll see a couple of specific examples of non-obvious community detection. And Graham may touch on this subject as well. Because we have this rich set of data that's highly connected, now we can bring to relief things that we wouldn't have seen before, but communities that lie within there. And in the case of fraud investigation, a lot of times that community is doing nefarious things and trying really hard to stay under the radar. But with some of these tactics, we can bring that up to relief. Next slide, please. And then finally, we can match patterns. So because the data is highly connected, we can start to see patterns within that data and match that pattern to other instances. You know, in the case of a graph database, for example, the way that things are connected, it basically create a shape. The relationships and the entities have a certain shape to them that we can basically use algorithmically to look through and see how those different patterns arise. So, you know, you can use this in positive ways. You can find positive patterns within the graph, behavioral patterns a lot of times over time, how people make different relationship connections. You know, it's kind of how social networks work in Customer 360, for example. You want to map out a customer journey. Well, you can look at negative behaviors too and start to map those out. And it helps you kind of pull out some of the anomalous activity. So just like you want to match a positive customer journey, you can also match anomalous, nefarious, potentially sets of activities. And you can basically match that pattern simply by the shape of the data in some cases. Okay, so we'll jump into a couple of specific examples. And we'll look to begin with just from the perspective of an analyst. So in this case, just to orient you in this solution, this is an analytics platform. And we are looking at transactions that have been flagged over geospace. So we're pivoting on geography first, and we just want to see a pattern. And so you see in the center of the screen, there's a map. We're looking at that. And we have occurrences of certain things that are on that map. On the right-hand side, that's a set of filters that basically allow us to build alerts that can capture and highlight things that we're seeing on the left. And that's drawing down into that highly connected data set and basically running rules over that. And we'll get into that in a little bit more detail in just a sec. On the bottom part of the screen, we see this temporally. So we can basically look at that histogram at the bottom and play it through time and see where there are spikes in risk activity. So in this case, we're looking at highly risked transactions. As an investigator, I want to see how that kind of peaks over time. And I can basically play that forward and see what happens on the map. So if we want to basically capture this novel information that we're seeing, if we're seeing a pattern or an abnormal spike, we basically say, okay, I want to take what the properties of the scenario in which this has transpired, and I want to capture it into an alert. So that's what's happening on the right-hand side. And then we build triggers around it in the system, and we say, okay, for this set of activities and these segments of people in this period of time for this region of geospace, do these sorts of things. Escalate this to this group if we reach this threshold. Spit out a report that has these certain segments, and basically we save that as an alerting mechanism that every time it's triggered with those sets of criteria, it's going to pop into the queue of investigator groups or what have you. And then we can drill into it and see the detail as an investigator if something trips an alert, where there are anomalous detections. So in this case, we've got 3 claims, and we can already see through virtue of the connections of those things, how a doctor is connected through to certain patients to actually a flagged disability report. And so this gives us a hint into, well, is this a pattern? Is this just a circumstantial link? Or is this something that notes repeated behavior that we want to drill into even more distinctly? And then if we want to take that same kind of view and view it from a customer service representative standpoint, we could click into an individual, for example, and we can see, you know, imagine this would be a customer service dashboard. And we can see for a specific person, some of the activity, almost like a customer 360 view where we're making recommendations around next actions and viewing that user or member's journey. We also see that flag now as a customer rep that there's possible fraudulent activity and that claims in fact have been put on hold. So this is kind of like the other side of that coin, where the analyst may look at things, the investigator may look at triggers that the analyst has set up, and then the customer representative, it feeds through to their system and they can look at that. Let's take a very similar set of use cases and walk through with medical claims. So these may not necessarily be fraudulent, but claims that have been flagged for various reasons. This could be upcoding, maybe a coder in a back office in a hospital fat-fingered an ICD-10 code or something, or there could be a pattern to it. I don't know, Scott, if you want to set up anything around the dashboard here as far as what we're looking at.
Sure. I think the point of this is, this is like Chris mentioned, there's multiple users, right? This could be a level 1 analyst. This could be an executive, as Chris mentioned. And now in this style of a dashboard, I could pick up a level 1 investigator. You can see that I may have alerts that are coming in to me from a third party. I may have investigations that I'm sort of undergoing or on way. And then I can see regions. Well, in my first version, many times what we see in customers, and Chris, as we talk about this here, we see this as a work queue. This is a level 1 a person who is saying, system, what should I do with this claim? It appears there's something wrong, right? So Chris, as I click into this, why don't you maybe talk a little bit about sort of what's going on inside of this screen, which is inside of the detail is why human did I want to do this?
Yeah, Scott. So, I mean, what you just walked through is exactly what we touched on earlier, which is there's a huge amount of data backing this, a lot of connected data that hadn't been connected, before. Now we're able to take those highly aggregate views from a dashboard, walk through to a work queue. So we've gone down from aggregate to 1 level down, and then a 3rd level down into the detail. Now we're starting to see, even in this basic detail screen for a specific set of, or a specific transaction, now we can see similar claims that are actually connected to it. So this is basically seeing the connections in a gridded format, and just by giving it a little bit of context with geospace and some heat map tabular information, we now take this specific thing that needs review, this claim that is put in front of a claims manager or an investigator to look at, and we've connected it now to over a dozen claims below. So you can start to see how that connected data links together.
Why don't you walk us through a little bit of what happens now? This is kind of setting up for Graham's section, but let's talk a little bit about maybe what the feedback is to the system.
Yeah. So this belies actually a very powerful and potentially complex set of events. But what Graham will talk about is how this got into our queue to begin with. What was the technology that basically tripped that alert and allowed some kind of anomaly detection to occur? What's happening here is we're putting the human back in that loop. And so the human is saying, I'm going to reject this, or I'm going to accept it. And here are the reasons why. Well, that's feedback to an adaptive learning model, a machine learning model in the back end. And that human in the loop intervention that says, you put this in front of me as a recommendation. I made this decision. Here are the reasons why I made the decision, is going to make that adaptive learning cycle faster and more accurate. So over time, as humans help train the system, it's going to become more and more accurate and be able to spider through and find more and more anomalies, make more connections around patterns.
Okay, great. Well, I think our next one here is, let's talk a little bit about now, how would a level 2 investigator maybe come up about this approach? What kind of things would they see? So we've talked about the dashboard for an executive. We've talked about a level 1 investigator. Now we're talking about somebody who wants to go a little deeper.
Yeah, so it's a little bit more open-ended. You see, they're not using work queues, or they're not being driven down from specific dashboard views. Now they're looking at geospace, and they're going to use a set of filters to analyze a facility. So now when they click into the facility's got a set of anomalies that have been assigned to it. And you see that pain clinic has a few flagged transactions, and its risk is pretty high. And when you see what anomalies are actually associated to those claims, you see that there's things around treatment not matching necessarily to the diagnostic codes. There's payout inconsistency. The temporal thing that Scott's hovering over here shows that there's something in time. The distance between two transactions doesn't make sense. You drill in a little bit deeper, and now we're getting into that graph, highly connected data, and we see physician linked to that pain clinic that's linked to a lot of different transactions that are linked to a couple of members that are even flagged. So now let's drill into the physician. And now we see that physician is linked to a few different facilities. So he's got credentials at a few different facilities, all of which are linked to a lot of different flagged claims. And those are linked to only a few members. So we're not looking at just kind of noise in, potentially unintentional miscoding. We're looking at something that's probably more nefarious. So we're going to take this and save that actual pattern, because we've confirmed now visually that is an anomalous pattern that is basically fraud. And we're going to click on that as saving to an analytic. And now it goes through a set of workflows that I think Graham will get a little bit more into. But it's basically the stem cell of an analytic that we can now run similarity matches across that data set and find those same sort of patterns in the shape of that data in the graph that look very similar based on the similarities that we encounter, the correlations around the group that we selected there.
So Chris, as we wrap up with this, what would you say the sort of core takeaways are from the different vignettes of demos? And I know you've got lots and lots more of those, but what are a couple of core concepts for folks to take away?
So if I had to boil it down, I would say that the technology that we're talking about here enables, a lot of connection of these siloed data sets. It enables a lot of things, a lot of analytics power, such as Graham said, but we still have to keep into context that there are a lot of different people in these workflows, and they need custom, views of that large set of data below the surface. And we've got to contextualize it in the right way and walk them through according to their workflow.
And it also seems that there's a sort of an alert management capability, which is the system is sort of letting us see things. And then it also seemed like you were walking through sort of a case flow and maybe even, sort of how those things are taken care of. So it sounds like that hits on some of our previous points about sort of process.
Yeah, absolutely. I mean, that's the guideline through all this stuff, is that the users have a workflow with this. There's a set of processes, so that it's very distributed, approval-based system, and we've got to play within those constraints in any solution that we entertain.
Super. All right. Well, Graham will be our next speaker, and Graham, why don't you sort of kick that off and walk us through sort of what machine learning and some of the technology in the great demo Chris just gave us.
Yeah, thanks guys for setting it up so nicely. This is setting, before I want to kind of jump into some of the technical specifics of how the analytics are enabled that we showed in the demo. But before we get into that, I want to show here a little bit of a high level about what we're driving at as an organization when we do enable those analytics. So typically what we see is this maturity life cycle inside of an organization, or in large organizations inside of a business unit, or even sometimes inside of a product, where we move from this data aggregation phase on the left-hand side into analytics, and then into product-based automated analytics. that allow our teams to operate in real time and make decisions that have implications for the future as those systems improve autonomously. So on the next slide, let me show you why you would want to do that. We have a few different ways that these technologies help out your products that are analytics based. And above all else, increasing the power, the accuracy of those systems, especially these detection methodologies we just looked at in the demo, is critical. It is the thing that drives revenue for our businesses. But additionally, it also, as Scott and Chris just showed in the demo, it also costs money for our investigators and analysts to look at and investigate false positives. So by using some of the technology we'll talk about, we're able to both increase that accuracy, let less things slip through the cracks, and decrease false positives and surface a bunch of flotsam that's irrelevant and costs us money to investigate. Using these systems, graph, machine learning, and advanced analytics, we're able to autonomously increase all of these metrics simultaneously. Let me show you a couple of the different algorithms here. We have a list on this slide of both graph and machine learning based analytics. And in reality, all of these things will be deployed in a complex analytics environment that's doing detection for customer analytics, fraud detection, these types of systems. When we couple them together, and this is the uncommon thing, and this is the thing we're seeing more and more this year and into next year, I believe, is that coupling between these graph algorithms and the machine learning algorithms you see on the right. That allows us to get to the next level of analytics. It really allows us to get to the state where our systems are being proactive and not just reactive to things that are going on in our business operations. I believe earlier we showed a little snippet of our logical flow diagram. So let me just cover that again, the piece I'll be talking about. Here, we're all the way into the stages past getting your data in, past looking at the mapping and deduplication into the critical advanced analytics and the exposure of those analytics in the UI you just saw that Chris and Scott showed. So I'll show you how this stuff works behind the scenes, how we surface those recommendations to the UI. This is a generalized look at how to deploy a machine learning graph algorithm. We take a subset of our graph over and over and over again, depending on which customer or which transaction or which claim we're looking at. We then extract the features from that subgraph, and sometimes this is actually done through interpreting the structure of that graph, the geometry of that graph. And we inject that stuff into a graph-based machine learning algorithm, which we'll talk about later on, and then surface the outputs back into the graph for persistence and then to the UI as you saw in that demo. So let me show you an example of this, a concrete example. This is an attribution system that is, this is an output from an actual TensorFlow model. And you see the graph there on the left-hand side representing a customer and their associated claims that are connected to doctors, that are connected to clinics, that are connected to prescription. That information is injected into that graph machine learning system. And the output, as you see on that, on the output side, the right-hand side of the slide, is that risk profile, those scores that we saw in the UI moments ago. Here's another example where we're looking at the overall characteristics of your customer base. We're able to use some modern techniques to do more advanced clustering, unsupervised learning, to understand where our customers exist in sort of like behavior space. So it's a fully autonomous behavior detection system that groups out our customers into the cohorts that we're interested in, whether those cohorts are cohorts like potentially fraudulent customers. They could be things on the flip side, like highly valuable customers. And those cohorts go as deep as the data that you have in your storage system. So we're talking about very, very granular cohorts defined by their interactions with claims and with other customers or service providers inside of your data structure. So once we do this, we're able to group out our graph into segmented cohorts. And we have a picture of what this actually looks like here on the next slide. That cartoon example is nice, but this is what it actually looks like when you plot some of this stuff out. So this is a subgraph, a very small subset of a graph containing seemingly unrelated claims until you put them in that graph structure. And then when we group them, when we cluster them out there on the right-hand side, you see those colorized cohorts of claims that have been grouped into risk categories based on their characteristics. Like for instance, Chris mentioned earlier ICD-10 codes. We ingest information like this ICD-10, and then we have information about services provided and associated claims and associated services. That allows us to get a holistic picture of those claims. Again, automatically, an algorithm does this and groups them out. And why do we care? And what we're showing here on the next slide is the reason this makes any difference at all. We're able to use these metrics inside the graph, and you see a few of them down below, connectedness and degree and things like this, that enable our algorithms to say, hey, these types of subgraphs, the subgraphs that look like this are risky or they're not risky. We can make recommendations about cross-sells and upsells. We can make recommendations about fraudulent behavior based purely on the shape of these subgraphs, and that shape is typified by those metrics down below. So interestingly, our algorithms are also now able to tell us why they're making the decisions they're making. And that's what we're showing here on the next slide. We have, this is a very simple example because it goes far deeper than this. And when we expose this information to the UI, as you saw with the demo earlier, and I'll repeat again in a couple of slides, the exposure into the UI is in a simplified form so that the end users like analysts, level one analysts can understand this information and make decisions in real time about it. But what our algorithm is telling us here is the most important indicators of why the decision was made by the algorithm. And this is how we reference that information in real time as a user. On the next slide, what we're showing is the little cartoon loop where we have the model, the actual algorithm making the decisions, feeding into the UI, and then the expert user, who could be like a claims investigator in this case, injecting information about what they see on the screen back into the system. And we saw an example of that. Here it is again. This is the actual mechanism by which those investigators say, hey system, in fact, that was a good decision. You've provided me a correct recommendation, and here's why. Or conversely, no, that was a bad recommendation, and this is why. Over time, what happens is the system improves its accuracy because it learns from the domain experts as those investigations are going on through this mechanism. So again, let's just repeat a screen you saw before. This is an adjudication screen, and we've surfaced here some anomalies, some anomalous claims. Those you can see as highlighted there in the screen in red. And as investigators click through into the reasoning behind the decisions made, they're able to provide some feedback, as you see down there on the right, lower right, about why those recommendations were the correct ones and what patterns and trends we're seeing in the data as we click through this stuff. So to summarize, there's 4 key components that go into a system like this. There is the monitoring of the signals, not only that are coming in our data, but also that are coming back from our domain expert users. There is the ability to automatically deploy new advanced analytics in a sort of online fashion called CI/CD, if you're familiar with that. The third one is the active learning component, which is the controller that allows that system to update itself based on the feedback it's receiving from our users. And the final one are those interpretability metrics that allow our users to understand why the system is making the decisions it is making. So with that, I will wrap it up and turn it back over to Laura. Thanks.
Actually, Graham, I've got a quick question for you. In your section, it seems like, and maybe you can lean in a little bit, is that section where you talked about those feature attributes, which are effectively changing. So it appears from what you showed there, the system is actually not only learning about what the human did, but it's also learning about what's changing in an investigation or those attributes on that one screen that the human saw.
Yeah, it's a good catch. I should have elaborated further. The interesting thing about that is that what happens is, because these systems operate online, they're always listening and responding, is that as the course of the investigation unfolds, and really more generally, as many investigations unfold simultaneously, the systems get better and better at understanding what's going on, and they adapt to those changes and respond by changing the decisions they're making, and again, showing those to the user.
Gotcha. Well, and then the other thing that I thought was very interesting, and sort of how you talked about that when we talked about the earlier, when we talk about sort of hierarchy of products, and we talk about our members, and then sort of what we're doing in the back office, it looks like this kind of a model actually then allows us to do much more than just what we think could be out of band or anomalies. Could you talk a little bit about sort of how that sort of expands over into maybe a customer 360 from our fraud section, or even into better policy creation?
Yeah, interesting. It's almost automatic in the sense that because you have all this data linked in the back end in this graph structure, you're able to see all of the related aspects of claims and customers as they sit alongside each other. So you can click through in that UI from let's say from a customer, or equivalently from a claim, and traverse out to the connected information. So if you're clicking through from a customer, you might see all the related claims from that customer. And if you're clicking through from a claim, you might see all of the related information, including customers, service providers, let's say if it's in the healthcare domain, you're talking about prescriptions and services rendered. That enables you to get a sort of a holistic picture of the customer and the transaction, which in this case is a claim, which is really powerful from a user standpoint.
Fantastic. All right. So with that, over to you, Laura.
Yeah, great. Thanks, guys. We did have a few questions that came through. And as a reminder, if you joined a little bit late, if you have any questions, feel free to drop them in the Q&A box. But in the meantime, we'll go ahead and get started with the few that we have. Let's see. There's one that says, can I use my current claims data, or does it need to be trading data specific?
Yeah, so it's definitely, I'll take that one. You can absolutely use your current claims data. And as I just mentioned, interestingly, you can actually use all related information as well, because unlike a relational data structure, traditional relational data structure, all of the information associated with that claim comes right alongside of it. It sort of sits naturally inside of the graph database because it's connected by those edges, so-called edges we saw in the UI that Scott and Chris demoed. So definitely, yeah, you can use your current claims data, and what you'll see immediately is that you have this sort of up-level visibility into the rest of the procedures as well.
Okay, thank you so much, Graham. We had another one that came through. We have some tools that we use internally today. Will those work, the graph and the UI?
I'll take that one. So everything that we talked about today, specifically the things that we demoed, are representations of a set of toolkits that we have that allow us to basically construct those sets of solutions in a very flexible way. They're designed to live within the ecosystem of other tool sets in harmony with workflows. So they can potentially fill the gaps. They can replace a legacy system. They can live alongside a legacy system to help give information, informational insight into something that's already been established. And I would say from a backend perspective, if we're talking about a graph database, a similar answer is in order here, in that that system could be the system of record, or it could be a place in which disparate systems are constructed together and stitched into a unified data model.
Okay, thank you so much, Chris. We did have another one that came through. How fast and what types of prototypes can we get started with?
I can take that one. That was one of our first examples that we talked about, the one that we did for ER claims data. Graham and his team did that in about 4 weeks. So the data analysis and sort of, identifying what it was. And then during the same time, Chris and his team actually built that user interface that we saw. So, anywhere from 6 to 12 weeks, these systems are pretty fast, and it really depends on how our customer partners are organized. In those cases, we were using the machine learning and the analytics department, and then we were also interacting with the claims adjudicators. So they're usually pretty fast. So good question.
Okay, looks like that was all the questions we had. So just as a reminder, we were recording today's session, so you will be receiving a follow-up email this week with a copy of the recording. If you want to reach out to anybody on the screen that you see right now for any questions, or there will be contact information in that email as well, we will be happy to get on a call and answer any questions that you have. Just want to thank everybody again for attending today's session. We look forward to the next one and hope you have a great rest of your day.